Today, we're going to look at the second in a series of labs on digital forensics, where we're going to start by creating a bit-by-bit digital copy of a USB stick. So here is the USB, and I will place it in the drive. And you'll recall from the previous lab that since I'm using this Oracle VirtualBox, I want to make sure that the Linux distribution is recognizing the USB. So I will give it 1 second to recognize the volume. It is labeled Store and Go, so that makes me happy. And we recall also from the last lab that the USB device is connected to /dev/SDB1. So that is exactly what we will be entering. We use account elevation. We use the DCF LDD. And we are going to indicate the input file as that /dev and the output file. This time we were going to put in, not in the temp directory like we did last time, but in a file that's in our user account's home directory. You will recall in the Linux world that this little tilde character is a shortcut for your home directory. So we will use that and get the process going. Because it's account elevation, we will need to enter our user account's password, and the blocks will begin to be written from the media device to that file in our home. And the writing process is complete. Next, we're going to use a hex reader tool named XXD to look at some formatting of that file that we just created. So let's use our account elevation, use XXD, name the file that we just made. And because lots of data that is output from a command can fly across the screen, and be difficult to read, we're going to use a Linux pipe, which takes that output and sends it off as input to another command. This one is the command less, and I recommend that you use man to look at both XXD and less to understand a little bit more about each one of those. And look what we have. We have some hexadecimal representations of the actual data in the file, and I'll give you a few minutes to take a look at this information on the screen, and we can use the space bar to page through the file, and there is some interesting information information that you can see, and we can hit the Q key on our keyboard to quit out of that command. You should be able to go back and analyze that portion of the video to answer the question about what you notice in the right-hand column that might be recognizable to you. Now, we are asked to enter some commands exactly as we see them. And we will be careful to put in the commands sudo space umount, another space, /dev/sdb1. And I will not hit the enter key until I have compared my typing to that which I see in the instructions. And now I will hit enter. It does not appear that anything particular happened, but you can trust me. The media on /dev at SDB1 has now been unmounted, and we are going to now use this dcfldd command to do some data writing again. Again, I will make sure that what I have typed matches exactly to the instructions. And once I feel confident, I can hit the enter key. And the writing process continues. Wow. It's completed. Now we can move on to the next instruction. We will type it again exactly as we see it. Sudo space mkfs period vfat. There is no spaces in that portion. Then a space dash capital F. It's very important in the Linux realm to use proper capitalization. Because capitalization, unlike in the DOS world, is recognized. After I type the sequence, again, I look carefully to make sure that I have captured the instruction exactly as it appears. Once I am satisfied of that fact, I will hit the enter key on my keyboard, and the action will continue. While that is completing, we can take a look at what's going to happen next. At this point, we're going to pretend that the USB, which I will remove this USB stick, will have just been handed to me by my supervisor in the forensics department, and we are going to complete that first lab start to finish. And the important thing as I do that is that you watch as I go through those steps so that you can make some kind of conclusion about what is going on. So I've been handed that USB stick by my supervisor from the forensics lab. I've inserted it into my USB drive. I want to make sure that my Linux operating system is recognizing that USB. So I will use the devices menu at the top of the hypervisor to check the box and see that it is indeed recognized. And now I can get going. Okay, you can see I actually inserted the drive, the USB stick, a little bit, jumped the gun on that. So I am actually seeing the partitions after the drive has been inserted. But you remember from the first issuance of the lab, the differences that took place. We've already answered that question, so we're really going to move down through the lab. And just observe what is happening. And change directories into that location. Now I'm at the point in the lab where I am going to issue that DCF LDD command, and thus I will do that. And just as was done in this first lab, we're going to put the digital replica in the /TMP/RECOV directory, not our home directory as we did in lab 2. I'll make sure that everything is typed identically to what I see in the instructions and hit the enter key. And blocks will start to be written to this go.dd file. We are getting close to finishing now. You can see the number of blocks written is approaching the 58,944, actually 58,880. And there we go. Now, from here on in to the remainder of the video, I will do very little narration. I'll just ask you to follow along in the lab and watch my actions. So we basically finished all the steps in Lab 1, which has become a subset of Lab 2. And it is your job now to think about what we did and what results you now see, to come up with conclusions about what is different and why this is the case. So, time to put on that thinking cap and think through it.